The introduction of carbon fiber to the aviation industry emerged in the 1970s. Originally, aluminum was used for aircraft wing construction, but the strong and lightweight characteristics of carbon fiber ultimately proved to be a greater source of material. Additionally, the flexibility of the fiber allowed wing systems to achieve good aerodynamic performance. One of the most famous examples of the use of carbon fiber is by Boeing aircrafts. William Edward Boeing began flying in 1903. In 1916, he created his own first successful aircraft. He dedicated his life to advancements in aircraft material. After Boeing passed away, his airlines continued to advance the material of the aircraft wings by using carbon fiber reinforced plastic composite. This is both economically and energy efficient. In 2014, it was recorded to save enough electricity to power 175,000 typical homes a year. Thomas Edison discovered the carbon fiber while creating the first incandescent light bulb. He baked thin threads of cotton at very high temperatures, which carbonized them, essentially turning the thread into a filament made almost entirely of carbon. Edison did not realize the potential of the material he had created because he was not concerned with the strength or tensility of the material, but rather its use in making light bulbs.
The production of carbon fiber is partially mechanical and partially chemical. It begins with the precursor material that is usually made from multiple carbon-containing substances, which is then drawn into long strands or fibers. These fibers are then heated to extreme heats without oxygen so it won't burn. High heat causes the carbon atoms to violently rearrange and expels all of the non-carbon atoms so that the carbons form together into a long interlocking chain of identical atoms. This is called carbonization. About 90% of the carbon fibers produced are made from the precursor polyacrylonitrile, while the remaining 10% are made from rayon or petroleum pitch.
Common items with carbon fiber include bike frames, automobile drive shafts, aircraft wings, racing helmets, fishing rods, and golf club shafts. Additionally, carbon fiber is used in multiple industries, the two largest being aerospace and sporting goods.
Carbon fibers have twice the strength and fatigue resistance as steel and is twice as stiff as aluminum, but half the weight. Advances in technology have caused its production to become much cheaper, and therefore the demand for the material has grown. The consumption and applications of carbon fibers are expected to continue to grow in multiple industries. The low weight to strength ratio has revolutionized many industries, such as transportation and sporting goods.
Growth in the use of carbon fiber in aircraft is mainly propelled by government spending and commercial aircraft orders. It is in the process of helping replace all of the older and less fuel-efficient passenger aircrafts by decreasing the weight of parts and therefore increasing their fuel efficiency. The unique, efficient properties of carbon fiber make it an industry-leading material, leading some to claim that it has endless possibilities in the future. Scientists predict that one of the most relevant areas carbon fiber may be used in for the future is the energy industry, as it can be employed to increase the effectiveness of fuel cells, wind turbines, and compressed natural gas storage mechanisms.
A single carbon fiber is thinner than a piece of hair. This is what gives the woven fibers their great flexibility and strength. Any damage done to one fiber does not propagate through the whole material. Rather, it is contained within a single fiber, and the woven fibers as a whole maintain their structure under more extreme conditions and manipulations.